Okay, we're going to look at working Unit 7 problems this week. It's going to take a couple of videos because we have to do multiple problems. We're going to start with exercise 6-7, 8, 11. We'll do 12, 17, 20, and then some IFRS problems too. Okay, the first thing I would like to do is look at, we would like to use learning activities. This is what I'm going to use to show you the problems that we're going to work. So you would just go to Unit 7, click Learning Activities. Okay, once the learning activities comes up, a couple of things to show you. First of all, if you go to additional resources, right, here's where the set B problems are, and you have the solutions in the doc sharing area. But just let you know, here's where the problems are, and then the solutions to these problems are in doc sharing. So one of the best ways to get good at this type of problem is to practice, and set B problems are great practice. I also wanted to show you that this is where you can find your present value and future value tables. These tables are universal. You can find them in a lot of places, but the reason I like these is because in Wiley, when you do the Wiley Plus homework, you need 5 decimal places, and these already provide you with those. Also, when I tell you what table 6-1, it's easier for you to find it, 6-2, 6-3, and so on. Anyhow, I'm going to go to reading content, and I'm going to get the exercises. And I'll just shut this because we don't need it right now. And I'll go to 6-7. What would you pay for a $50,000 debenture bond that matures in 15 years and pays $5,000 a year in interest if you want to earn 8%, 10%, and 12%? All right, so let's go ahead and look at this. Okay, so it's an 8% bond. We know that it's a 15-year bond. They tell us it's, N is equal to 15. So in order to do a bond, we needed to pay back the principal, which is $50,000 bond, paid back in 15 years. And we know the interest rate is 8%. If you use table 6-2, you can see how to get the present value of that one-time payment. So it's a one-time. Our company's selling a bond, which means we're taking out a loan. So let's say we sold our bond, a $50,000 bond to John Smith. In 15 years, we're going to pay John Smith back $50,000. What is that $50,000 worth to us now? The present value. That's why we use table 6-2, which is the present value of a single sum, because we're only going to pay back the $50,000 once. But we also have to include in the value of the bond the interest payments. Those are going to be $5,000 a year in interest, right? And so we would want to go to present value of an ordinary annuity. Why that table? Well, because we're going to be getting the same amount back year after year after year. I'm not saying the same amount back. That's what they're going to be, the interest amount we're going to pay every year after year after year. It's $5,000, same amount. Okay, so we're going to be paying the same amount year after year, so we want to use an ordinary annuity, the present value. It pays at the end of each year, so that's why it's an ordinary annuity. If it paid the $5,000 at the beginning of each year, it'd be an annuity due. So that would be a different table. So 6-4. So now if we add up the present value of all the payments and the present value of the amount that we're going to pay back in 15 years, put those together and we get the amount that's that the value of the bond is at 8%. If we want to do this for 10%, we would use the same tables. Instead of using the 8% column, we would use the 10% column. If we want to do the 12%, the same thing. So I'm not going to do each of those for you. I'll do one, and then I'll let you figure out the others. It should be pretty straightforward now that you know that. Now let's go ahead and look at exercise 6-8. Okay, in 6-8, we have an interesting situation. We have Clarence Weatherspoon. He wants to retire on his 55th birthday. He wants to create a fund on an 8% basis, so he assumes he's going to get 8%, which would allow him to withdraw $20,000 a year in 2018 to 2021. So for 4 years after he retires, he wants to withdraw $20,000. Maybe he's got a bucket list he wants to take care of for those 5 years. Who knows? But be that as it may, to get this fund, he needs to figure out what he needs to contribute for 4 years, 14 to 2017. So 14, 15, 16, 17, 4 years. So he's going to put 4 sums in, not sure how much, but he needs to put enough in so that at the end of 4 years, he can start taking $20,000 out each year. So in order to do this, you kind of have to do it, I guess, backwards. Part A says, how much would the fund balance, how much must the balance of the fund equal at the end of 2017 to be ready for him to start taking out $20,000 a year for 4 years. So let's look at this. So what we're going to do again is we're going to deposit from 2014 to 2017 for 4 years an amount of value that we're not sure about. Then from 2018 to 2021 we're going to draw $20,000 a year. So we need to know at this point how much money do we need to be able to withdraw $20,000 a year for 4 years. So the first step is, what would you need to have in the bank at this point? So we can figure that, how much this needs to be to withdraw $20,000 a year, then we can figure out how much to put in. So we're going to kind of go backwards with this. We're going to figure this amount first, and then we're going to figure out each of these payments later. So what would you need in the bank at 2018 to withdraw $20,000 a year? 4 periods, we know it's 8%. We need to do a present value of an ordinary annuity do. So what would the present value of this ordinary annuity of 4 years need to be? So 20,000, I go to my table, which is table 6-4, right? 6-4, present value of an ordinary annuity. I put in 4 periods, 8%, I get the number 3.31213. $20,000 is my annuity. That's the same amount that we're going to get each year. So 20,000 times that gives me 66,000. So right here we need to have $66,000. 66,234 to be exact. So now we can figure out how much we need to save for 4 years to get to this future value. So from here to this future value of 66,243, what do we need to put in? So here we're going to use a different table. We're going to use table 6-3, which is a future value of an ordinary annuity. Future value of an ordinary annuity. So if we go to 8%, 4 periods, in table 6-3, we get that 4.50611 times what number is going to give me 66,243. So we're going to need to divide both sides by x, basically, right? I'm sorry, divide both sides by the 4.50611 to leave the variable by itself. So 66,243 divided by 4.50611 gives me what? And the answer is 14,701. So Clarence needs to deposit in 2014 through 2017 $14,701. At the end of those 4 years, he'll have 66,243, which will be enough to let him take $20,000 a year out from 2018 to 2021. Alright, so I'm going to stop here and I'll pick up with exercise 6-11 next in the next video.